Hi, this video tutorial is on software requirements analysis, and in this video, first of all, we are going to look at what exactly are requirements so that we are able to understand what requirements really are in the context of a software project. Then we look at the different types of requirements, and then we look at other sources of requirements in case you do not have the software requirement specification with you. Then we look at examples of how you can analyze the software requirements given to you to find out the problems with those software requirements. So let us get started. First, what is a requirement? A requirement of a software system is a functional or non-functional need that needs to be implemented in the system. So functional may mean that if it is a system that provides some kind of service to a particular type of user. So what kind of service will it provide to that user? For example, in the context of education, it can be a requirement saying that when the student looks at their profile, they'll be able to use the system to look at their existing profile information. The software requirement can also be a non-functional need in the sense of it can be a performance requirement. So there can be a non-functional need that every page of the system should be visible to the user within 5 seconds. So basically, a software requirement is a functional or a non-functional need that needs to be implemented in the system. Software requirements are usually expressed as statements. So each requirement is expressed as a statement. In order to clarify the requirement further, there can be an example given with the scenario that gives more details of how exactly the requirement is supposed to be implemented in the system. Now let us look at different requirements types. First of all, we have the business requirements. Business requirements are the high-level requirements that are taken from the business case for the project, and we'll look at examples of each type of requirements. More detailed are the architectural and design requirements that show the overall design required to implement all the business requirements. And the most detailed are the system and integration requirements. System and integration requirements can appear in the form of system requirement specification, which is the detail of each and every requirement. And it can also come in the form of user stories, which is really describing the requirements in everyday business language. So let us see examples of the three types of requirements. So first of all, let us look at a business requirement. So this is a sample business requirement document that I have taken from the web. So as you will be able to see that it is a very high level kind of a document containing high level requirements. So let us see few examples from here. So it gives the overview, etc., and this is a section where it gives the requirements. For example, section 4.1 of this sample says that there is going to be a banking services system. It's provided for 4 Asian countries in the Asia Pacific, and the names of the countries are given. Then it just says that in which country which major functionality. For example, in Singapore, account summary and fund transfer functionality will be available. In Malaysia, account summary and bill payment functionality will be available. Other high level requirements can appear in this business requirements document. The master customer information will include all these elements for a new mobile internet user, like a unique user banking ID, bank branch, full name, etc. So this is a high level kind of a requirements. This is an example of the architectural requirements. So these are more detailed than the business requirements, but still they are at the architectural and design level. If you have not viewed our V model tutorial, please view that so that you are able to understand these things in more detail. So this contains the use cases. So the major use cases in the architectural and design requirements are given over here: login, register for courses, maintain student information. Obviously it is related to an educational system. So let us look at a few requirements. For example, we can see the login use case. The brief description is given. This use case describes how a user logs into the course registration system. The actors starting this use case are student, professor, and registrar, which means that the login functionality in the system can be invoked by a student, a professor, or a registrar. At the lowest level, we have the system and integration requirements. This is an example of the system requirements specification. So this is given in very great detail so that coding can start from here. So here it says, for example, student self-service is the module, and the student can make changes to his or her courses, and the personal profile of the student will contain the student address, their student authentication, that is PIN, their email address, fax address, and stops, etc. For registration, they have to give registration status, course status, current schedule, register for a course, add or drop a course, etc. So this is in the most detail. Now let us move on. Now sometimes if you are working in a project, it is possible that you do not get any requirements documentation to work with, but still there are other sources of requirements, and before you start your software development or testing, you need to gather the requirements information from these other sources so that you can base your software or base your test design on these requirements that you gather from the other sources. First of all, it's a knowledge transfer. So if you are new to the team, the existing team members may already be aware of what are the requirements they are working towards in implementing in the system, so you can get a knowledge transfer from those. You can always talk to the business analyst, product manager, developers in the project, project manager, or the client to get what are the main requirements and to get some details of the requirements. Then you can also analyze the previous system versions, work with them to understand what is the requirements that are already implemented in the system, so that you have a familiarity with the existing requirements. It is possible that there are older requirements documents available, and you can look at those along with the previous system versions to come to know about the existing requirements already implemented in the system. Then you can also look at the past bug reports. Some of the bug reports are turned into enhancement requests which may be implemented in the current release of the system. You can get information from those. You can also look at the install guide if it is available to see what are the existing installation requirements. And finally, you can leverage your existing domain or industry knowledge to understand what the existing system is all about and what is the new requirements that the team is trying to implement. Whatever requirements you get from these other sources, make sure to document them in some form and get them reviewed from the other knowledgeable team members, so that you have a good idea of what is the current overall set of requirements, including the previously implemented requirements and the new requirements that the team is working to implement in the system. And then there can be legal or statutory requirements that every system in that category has to implement. Now let us look at how to analyze the requirements, and let me jump into an example over here. So here in this example we have 3 columns. First is the requirement quality. When you look at all the requirements, whether you have got the requirements from a requirement document like a software requirement specification or architectural requirements document or even business requirement document, or you have gathered your own requirements, you need to look at different qualities of each and every requirement. The next column is example of a bad requirement with some problem, and then the same requirement converted into a good requirement once the requirement problem is removed. So each and every requirement that you have should be atomic. Atomic meaning it should be at a very low level of detail. It should not be possible to separate it out into components, because requirements have to be kept simple if they have to be implemented completely and correctly without any confusion. So example of a bad requirement is, let us continue with the example of a system being developed in the education domain. So students will be able to enroll to undergraduate courses and postgraduate courses. This is not atomic because it talks about two different entities of the system, undergraduate courses and postgraduate courses. So obviously it's not a good requirement, it's a bad requirement. The corresponding good requirement will be to separate it out into two requirements. So one just talks about enrollment to undergraduate courses and the other talks about enrollment to postgraduate courses. The next requirement quality that each and every requirement should have is that every requirement should be uniquely identified. So here we can see that there are a couple of requirements, enrollment to undergraduate courses and enrollment to postgraduate courses, but the ID given for both is 1. So which means that if we are talking about a particular requirement ID of 1, it is not clear which exact requirement we are referring to in other documents or parts of the system. So separating it out with unique IDs, so the requirements can be rewritten as the section 1 is course enrollment and it has two requirements. 1.1 ID is enrollment to undergraduate courses and 1.2 ID is enrollment to postgraduate courses. Then each and every requirement should be complete. Here is an example of a bad requirement. It says a professor user will be able to log into the system by providing his username, password and other relevant information. Well, what is the other relevant information? So it is not clear. So when that other relevant information is spelled out so as to completely flesh out the requirement, it becomes a good requirement. A professor user will log into the system by providing his username, password and department code. So this contains all the information. Then each and every requirement should be consistent and unambiguous. So here for instance we have a requirement, a student will have either undergraduate courses or postgraduate courses but not both. This is one requirement, and there is some other requirement which says some courses will be open to both undergraduate and postgraduate students. The problem here is that a student can either go in for undergraduate course or a postgraduate course but not have a mix of both, which seems to indicate that the courses are divided into two categories. Undergraduate courses are separate and postgraduate courses are separate. But the other requirement seems to say that some courses are both undergraduate courses as well as postgraduate courses. So obviously there is a conflict over here, and this needs to be resolved by whoever is documenting the requirements. So converting it to a good requirement can be just removing the other conflicting requirement. So it says now a student will have either undergraduate courses or postgraduate courses but not both, which means that every course will be marked as either being an undergraduate course or a postgraduate course. Then each and every requirement should be traceable because there are different levels of requirements. We already saw that at the top we have the business requirements, then we have the architectural and design requirements, and then we have the system and integration requirements. Now when we convert business requirements to architectural and design requirements, or we convert architectural and design requirements to the system and integration requirements, there has to be a traceability, which means that we should be able to take each and every business requirement and map it to the corresponding one or more software architectural and design requirements. So here is an example of a bad requirement. It says maintain student information is mapped to BRD, requirement ID is not given over here. So converting it to a good requirement, it says the same thing, maintain student information, and it is mapped to BRD requirement ID 4.1. So there is a mapping should be present for each and every requirement. Same way we have mapping between high level and low level requirements. The mapping is also there between a system and integration requirement to the code that implements that requirement, and also there is a mapping between system and integration requirement to the test case which tests that particular requirement. So this traceability is all across the entire project. Then each and every requirement should be prioritized, so the team has a guideline, so which requirements they need to able to implement first and which can be done later on. Here an example of a bad priority, you can see register student, maintain user information, enroll courses and view report card. Each and every requirement is given at priority 1. Each and everything cannot be at the same priority, so the requirements can be prioritized. Now this is an example of a good requirement. We can see that registered student and enroll courses at the highest priority, maintain user information comes below at priority 2, and then we have the view report card. Then each and every requirement should be testable. An example of a bad requirement which is not testable is each page of the system will load in an acceptable time frame. Now there are two problems with this requirement. First is that each page, meaning that there can be many pages, there can be many different pages. So first of all, it just is going to blow up the testing effort that is required, because the system may have thousands and thousands of pages. The main problem with this requirement is that it says each page of the system will load in an acceptable time frame. Now what is acceptable time frame? Acceptable to whom? And people can always argue that this is acceptable or this is non-acceptable, because this is not objective or specific time frame given over here. So this requirement is not testable. So we need to convert a non-testable requirement into a testable requirement. So here is the example of the good requirement. So it specifically says which pages we are talking about. So we are talking about register student and enroll courses pages, and the acceptable time frame is also given within 5 seconds. These two pages should always load within 0 to 5 seconds. So this is how we have to look at each and every requirement at the appropriate level. For example, if we are going to build the software with regard to the system and integration requirements, we have to look at the system and integration requirements given in the software requirement specification or the user stories, and apply this check to each and every requirement. That each and every requirement should be atomic, uniquely identified, complete, consistent, unambiguous, traceable, prioritized and testable. Same thing goes when we have to do the test design, create the test cases. Again, we have to look at each and every requirement given in the software requirement specification or the user stories, and apply each of these checks to make sure that the requirements are good requirements. They satisfy all the good requirement qualities. So I hope you were able to understand how to understand the software requirements given to you, how to analyze the software requirements, and how to test those software requirements to find out if there are good requirements or there are certain bad requirements. If there are bad requirements, then those requirements need to be converted into good requirements, and then software development and testing can begin. So that is all for this video, and see you in the next video. Thank you.